Okay, in example one, we want to determine a translation vector. So we want to basically say, what is the vector under which something has been translated? So which direction and how far is it moving? It's kind of the simpler way to say it. So for this one, was there a translation that could move you from JKL to J prime, K prime, L prime? I don't think so. A translation would just be movement, right? It would just be um, moving it in some direction. This is clearly a reflection, right? This is like what we just were working on in the previous lesson, which was reflecting over kind of a mirror, making a mirror image. So these two are not translation. And the thing that they're using, the part of this, the distance between each pair of corresponding vertices is the same. They're saying that's not true, and that is why the technical definition of translation doesn't work. Um, Regardless of just looking at it and saying, yeah, that doesn't look like a translation to me based off what we saw, the actual definition that said the distance between each pair of vertices is the same, okay, that is technically why this is not a translation, because this distance is much greater than that distance. Okay, we want all of the distance between our translated points to look the same. Okay. Now, if we want to check this one and say, what is our vector of translation? Looks like we've got some awesome formatting here. Find the translation vector, I think is what that says. Actually, almost looks like they've taken the words find the translation and translated it over half a letter. So you've got like another image. I don't think that's on purpose, but it's kind of funny. Anyways, something that's cool about these vectors is that you don't need to specify the magnitude and direction. So you don't have to say the length is the square root of 24 and the direction is 40 degrees. Those are things that are kind of tied up in the notation here. So as long as your notation specifies how far over and how far up, so kind of like your slope, your rise and your run, as long as you specify that, you can figure out what the angle is using a subject we call trigonometry. You can figure out the magnitude using Pythagorean theorem. So really all we need to write down to describe a vector is how far does it go to the right, how far does it go up? Or a different way of saying it, x-axis and y-axis, because it might go left and down or left and up. Okay, so ours, I'm seeing that from L to L prime, I go over 1, 2, 3, 4, 5. So to the right, positive 5, and up 3. Okay, so I would say A right here is our vector, 5, 3. Okay, and that is all there is to it on example number 1.